Good morning, good afternoon, and good evening, depending on where in the world you're joining us from. Welcome to our AI Demo Day, brought to you by our headlining sponsor, Mistral AI, and sponsors SAS, Fivetran, and Precisely. I'm Jenna Holland, Director of Marketing and Digital at Data Science Connect, the world's largest data and AI community. Today, we're excited to welcome attendees from all over the world for an exclusive virtual event showcasing the most innovative AI solutions through concise 10-minute demos. At DSC, we value your time and have designed this event to provide impactful demos that cut straight to the core of leading edge technologies. So you'll be able to identify solutions that meet your business needs and connect directly with the top leaders of pioneering AI companies. We're honored to host a distinguished group of experts today from some of the leading pioneers in AI. Jenn Cunningham, Product Marketing Manager at Mistral AI, Kelly Kohlheffer, Senior Global Director of Partner Sales Engineering at Fivetran, Robert Blanchard, Principal Data Scientist at SAS, and Ben Tuck, Product Marketing Manager at Precisely. Before we begin, a few housekeeping items. To make this feel a little more in person, we suggest you add a photo to your profile and include your bio, LinkedIn profile, and other information you want your fellow attendees to see. Next, please take advantage of the Q&A and chat features throughout the webinar. Presenters may address your questions during their allotted 10-minute time slot or respond directly in the Q&A and chat sections. If you're wondering where your organization stands compared to others on your AI journey, check out the poll questions in the right sidebar. And finally, if you'd like to learn more about any of the solutions you see today or book a full demo, click on the calls to action below throughout the webinar from our partners. Now, without further ado, let's kick off Demo Day. Hi, Jen. Welcome to the stage.
Hey, Jenna. How are you doing?
Good, good. Thanks for joining.
Oh, thanks for having me. Really excited to be here and chat with everyone about Mistral. I know we are quite tight on time. Should I go ahead and jump in?
Yes, please do.
Awesome. So hi, everyone. I am Jenn Cunningham. I'm a product manager at Mistral. I do have a timer going to make sure I'm honest on the 10-minute mark. If you aren't familiar with Mistral, we are a frontier AI lab making LLMs for the enterprise, so offering fine-tuning and customization of our LLMs to solve your business's hardest problems. In addition to our general purpose LLMs, we have some really fantastic specialist models, OCR, our OCR model for vision, and Foxtrol for our audio model. So I'm actually going to be walking you through those today. So I'm going to be showing you everything in our studio platform, which is really where you can make these ideas of AI processes real for your organization. It's one platform to build, deploy, and govern your agentic AI systems. So while I'm going to be showing you this in the platform, please know that everything I show will also be able to be accessed via API, and I'll actually show you what that can look like in my OCR demo, which I'm going to do first for you today. So with that, I've got just under 9 minutes left. I'm going to go ahead and share my entire screen, and I have all of my notifications disabled. So let's hope it goes well. Now you should be able to see my screen. Great. And this is our studio platform. So like I said, I'm going to start off with Document AI. Now, Document AI is really fantastic for working with really like document heavy use cases. As you can imagine, I'm going to be showing you one document use case, but if you can imagine, we process thousands of documents for different organizations. In this scenario, I have totally just fake data for an insurance company. This is an annuity application, but we have handwritten information across here. So if you can imagine, this is all financial information that you really need to get right, but the form has been filled out, looks like mostly by hand. So I'm actually most interested in this second page here. So I'm just gonna pull that out. There are no images in this file, so I don't need to worry about that, but I would like to know what our headers and footers are. And then we have different ways you can extract the tables. I'm just going to leave it as inline markdown. Again, no images to annotate, but I am really curious about these confidence scores because I want to know, how confident are we that we're capturing this information correctly? So you can see up here, we have a 95% confidence score for the document. Minimum is 16%. So if we scroll down, we can kind of see what that looks like with the different color coding here. We have our headers, our titles, our bounding boxes to highlight this. I'm quite curious about this bottom portion because I genuinely can't read it. So if we go down here, we can actually see where we do have some portions where we're seeing a lower confidence score. And these would be good fields for person to actually double check and make sure that that's correct. So this is what we're seeing in Studio, but if you wanted to actually build a workflow for this over in our left nav, you can do that. My friend Joffrey was kind enough to help us out with a demo to show you what this could look like in our Vibe platform. So Vibe has two modes, work and code. This is focused just on the work mode where you can use connectors or workflows to just use natural language to run through big business processes that you may have instead of working through a CLI with code. Now, he's built this document ingestion workflow for patient intake forms. It's going to take him a little bit of time to actually pull up the form, so I'm going to jump ahead. But what you can see here is we have a paper intake form. It looks like this is an actual photo, like a JPEG file. Yeah, JPEG file. So we have handwritten information, text fields, but also presumably really important for a doctor's office to be able to pull this correctly. And we're looking at anything with below a 90% confidence score here for a person to review. And so he's looking at the whole document here in the Vibe terminal. So this is similar to the UI we just saw in Studio. And then he's able to scroll down line by line and make sure we're getting the right information. So like, for example, pharmaceutical information, this is really important to make sure we get right. Ventime, it actually is Ventolin. Imagi should be Inagi. And then he just approves and indexes the file. And all of this information, he's able to review the updated file and then able to push this to whatever fields are really necessary to capture this information, which is great. Now I have just under a little over 5 minutes left, so I'm going to jump ahead and move further up on this left nav to talk about our audio offering. So we have two really fantastic building blocks for audio, speech to text and text to speech. You can string these two solutions together for a conversational AI agent. I'm going to be showing them to you separately as standalone solutions for specific offerings you may have. So I'm going to start out with text to speech for any sort of communications, conversations, anywhere where you need, a voice AI to speak on your behalf. This is really a fantastic solution for that. I'm going to be walking through a podcast example with my friend Melly's voice. So we do have voice cloning as well. And so if I go here, I can pull Melly's voice for podcast, for any sort of content we may be looking to do with her. We just have a cheeky little button to kick off and play. So all I have to do here is generate the speech. So if you can imagine, if you had a longer text form, you could do that too. Great. Thank you, Melly. Now, if I want to go ahead and reset though, because Melly actually speaks English and Spanish, and she was kind enough to let me clone her voice in Spanish. We did some Shakira lyrics for our quick one-shot clone, which was great. And if I just start this podcast in Spanish again, takes all of 2 seconds. Oh, that was odd. I don't know what that was about. Let's reset and do that again because it should just be saying hola de otro episodio, no? But if we go here, Melly in Spanish, I don't know what that was about. Here we go. There we go. But yeah, so if you can think of content that you're trying to generate in different languages, if you're trying to reach more audiences at an international level and you just genuinely don't have the manpower to create voice content, this is a great way to do that. Now I'm going to jump over to speech to text. Transcription is a really powerful use case. We do some really interesting things with like manufacturing and factory floors and capturing notes and QA processes there, or working in like airfields for airplane testing where you have a lot of satellite distortion. We offer two speech to text models, offline and real time. So I'm going to start with offline, and then I'm actually going to need some help with real time. Now I'm going to start with this. I could not go to a factory floor, but I am normally based in London and was able to go to a pub for the England-Argentina match. So if I go here, I can see I've uploaded just an audio note. We see that Lynn just scored against Argentina. We're seeing how Voxel works. It doesn't necessarily make a lot of sense, but we're talking about England And actually Argentina was captured. Okay, so we can get Voxtral in there, and then we can retranscribe. And everything's pulled together perfectly. We understand what they're saying. And then ultimately, this is for background noise. I'm going to turn this down a little bit. So if you can imagine factory floor, pub, wherever you may need to transcribe. Also, if you're thinking subtitles, or again, on that international language piece, this is Mistral is headquartered in Paris, so I would be remiss to not try French. This doesn't change the actual content that's being said, but you're able to also get subtitles there or a translation there. So I'm going to start over. I'm going to move over to real-time translation in our last minute. If I can get some audience participation, I'm going to stop sharing for 30 seconds. If in the chat, oh, you're not hearing the system audio. Okay. That is, I'm quite tight on time, so apologies. I'm going to have to jump ahead, but please try out the audio yourself. Now, if we can, could I just get a verb, a plural noun, an adjective, and another verb in the chat if you have any terms that you would like to join? Run, great. Dance, awesome. So let's go with dance for a verb. Can I get a plural noun? People, great. And what about an adjective? Great. Okay, great. And then verb. I'll just do meow since we really like cats at Mistral. Sorry, I'm running slightly over. Jenn, if you can give me 20 seconds just to finish up with transcription to show you guys here, and I can just share screen. Here we go. But here we go. So if we go to real-time transcription, I have a little Mad Libs for you guys. So here we go. So Mistral is the frontier AI lab for solving the world's hardest problems. Start in studio, build, dance, and run agents and people with great models like Voxtral for audio and OCR for vision. Meow into VibeWork or Vibe Code. And if you want to try it yourself, you can build at console.mistral.ai with cookbooks at docs.mistral.ai. Yeah, and so there's no biasing in that. Thank you guys so much for your time, and I will let Jenna take over. Thanks.
Thank you so much, Jen. Great having you on the stage. Next up, we have Robert Blanchard from SAS. Welcome, Robert.
Hey, thank you. It's great to be here.
Great to have you.
So let me go and share my screen real quick. Here we go. Hopefully everyone can see my screen. Excellent. All right, so today I'm going to talk with you about defeating synthetic forgeries with OCR agents and vision models. And I'm going to be doing this work within SAS I built this agentic flow within SAS and SAS is an enterprise-ready agentic AI ecosystem, and it contains all the components that you need to build out your agentic flows and your tool sets to solve your problems. I'm not really here to talk to you so much about SAS but more just to show you the really cool solution that I built inside the tool set. So I've been an educator for many years of my professional career. So as any good educator, I'm going to start with a quick quiz. Which image is inauthentic? Just go ahead and type in your answer into the Q&A. I'll give you about 10 seconds to be quick. So we've got A. And if you're shy and you don't want to type it in, just kind of think which one. We've got A, B for sure, B, C, A. Okay, great. Thank you everyone for participating. C, this was actually a really hard example because C is a real image, but I have synthetically manipulated this real image to add damage around the door. And this really presents the problem, the challenge that we face today. Humans, we can't really discern what we see to be real or fake or manipulated. And in fact, the tool set today can easily allow you to manipulate images. So here I'm doubling values in a receipt, and you can see the juxtaposition down at the bottom. Forgeries have climbed from 2023 to 2024 by 244%, from 2024 to 2025 by 300%, 2025 to 2026, it's in the thousands of percent, depending on where you pull your stat from. And it's so easy to do this. So we've had a lot of customers who have come to us and said, "Hey, we've got this problem. We're inundated with synthetic forgeries. How do we solve for this?" So we developed a solution that begins with a front end, and this is where you'll deposit your images. Now, and today I'm just using a simple Streamlit web-based app just as a dummy environment to upload images, but that's going to connect to the deployment flow on the back end. Of course, you at your company and your organization probably have landing pages where your customers will upload bank statements, W-2s, pay stubs, or whatever documentation that you need to ingest in order to make a decision. When information and documentation is ingested on the back end, it's going to kick off uh, an analytic workflow. That's this combination of models that are going to collaboratively work together. And I'm actually using SAS AI's intelligent decisioning to build out this framework of these models that are going to collaborate together. Each model is a specialist in their own right that are going to take a perspective or look at the problem and try to discern the authenticity of the evidence that's provided. What comes out of this workflow is a table that's going to populate a dashboard. And this is where your internal auditor can look at the evidence that's presented to make a final determination. The human in the loop is still important, but the human needs to be augmented with these more powerful tools. So without further delay, I'm going to get into the demo. So let me drag over my, it's a very simple coded app. So I'm going to upload a few images. I'm going to pick some IDs. I'm going to pick this image of a car. Here's a North Carolina ID, this receipt, and then a real image of a car and a real image of a receipt. So I'm going to submit these for analysis. So what's being kicked off on the back end is this flow that you see here. This is inside of SAS Intelligent Decisioning. It begins with a computer vision forensic model. This is kind of a dual stream model where on one stream, we do a semantic view of the information. And on the other stream, we're applying forensic transformations that highlight characteristics that we typically see within generated images or synthetically manipulated or manually manipulated images versus real images. So real images, they actually have hidden characteristics within them, as well as synthetic forgeries or manipulated images also have, um, oh no, my system's about to restart. Hopefully it doesn't occur while this is going on. So that's the first model that the evidence uh, hits. So this model produces an authenticity score, um, or a probability of authenticity. Next, we've got a classification model, simple classification model. This is just here to organize the information. You'll notice that I've got receipt docs, government IDs, bank statements, and cars. Receipt docs, government IDs, and bank statements, they all have a sub-decision flow, which I'm going to drill down into. But notice that cars does not have that sub-decision flow. The reason that cars does not is because in these other sub-decision flows, we're actually applying OCR to extract information. Of course, an image of a car doesn't have any relevant text information that we really want to capture and categorize. So in this flow, we've got OCR. We apply OCR to extract the important information from that document. Here it's a bank statement. And then we check that document or that text for an IPI attack. That's an indirect prompt injection attack. We're going to use an LLM, or you could insert an agent here. An agent I kind of deem as different from an LLM because an agent has access to the different tools within your system or external tools, however you'd like to frame it or position it. But here we have an LLM. So we check the OCR extracted text for an IPI attack. This is where a malicious person can put in hidden text that you necessarily won't see in the image that can have the agent do something it shouldn't do. So especially if through MCP it has access to the internet, it could say, go here, download this payload, and it could corrupt your system. So if an IPI attack is detected, we circumvent around the LLM agent to protect the system. If it's deemed safe, then we go to the LLM. So here we also have a prompt. So the LLM or your agent is going to receive the OCR text as well as a prompt. And if you're going to use this flow, we copy and paste, give this to you. The prompt you're going to need to change because it's for your business context. So here you are a document analysis assistant that evaluates OCR extracted banking and financial documents and so forth. We go back to the ID flow. Now notice over here on the OCR, we actually have additional models. So in some of our first iterations of this, we asked the LLM to produce not only a summary of that OCR extracted text, like consider the grammar, consider the math, consider the context, and provide a summary of authenticity, but we were asking the LLMs to produce an estimate of authenticity. And what we noticed is that the estimate is kind of made up. The LLMs really weren't great at estimating well, great at summarization, great at natural language processing and so forth. But estimations, they're kind of all over the place. So we replaced that estimation with a deterministic estimation. Here we're just applying single value decomposition and tabular model on top of that. And then we bring it all together with a global adjudicator that takes in the posterior of the forensic computer vision model, as well as the context of the extracted text. Now notice government IDs and bank statements don't have these later deterministic models because for the data I used to create this, I didn't have a lot of real government IDs or a lot of real bank statements that I could leverage for this example. So what comes out of here is a data set. I'm going to go ahead and go to a dashboard that I've created. And you can deploy this within SAS AI, or you can containerize deploy outside and use whatever dashboarding tool that you like. So I'm going to start up here at this first document. Here we've got government document. We've got computer vision explainability. You notice the heat map's kind of all over the place. Behind the scenes, we're using a custom version of RISE, and RISE has high faithfulness in terms we can trust what the model is saying it's activating on. However, you have to inference many times, thousands of times. And this is currently deployed on my current system, which has CPUs. And so I've only have it inferenced 3 times in order to generate this model explainability. So I'd really need to bump this up to 1,000 or so times. I could also switch this out for a different interpretability method, like one of the gradient-based methods if I want to keep my compute costs low. Next, I have this error level analysis. This is one of the forensic transformations that we apply on the forensic stream of the model. And this highlights superimposition that's happened. If someone crops out a signature and pastes it on an image of a check, or they change numbers around, those superimpositions can be highlighted in lossy formats. Noise residual analysis. This forensic analysis highlights noise that is present in an image. Real images have noise. If you take a picture with your iPhone, there is noise that's actually imprinted in that image. We don't see it, but it exists, whereas synthetic images, they're actually very clean. We have our data safety determination. This was safe. Model determination, authenticity score. So this is not very authentic. And then authenticity distribution. So if you have a customer who uploads a bucket of documents or evidence, maybe 20 different pieces of evidence, you can look at the distribution across the evidence. And then down here, we have our OCR summary. And you can see, everything looks okay. The summary, I go to the next document. And this one actually calls something out. It says, however, the date of birth suggests that the age would be inconsistent. And I look at the date of birth, 1883. She actually looks very young for being well over 100 years old. So I go to the fake car. Notice there's no document summary down here. There's no OCR. Here's the North Carolina ID. Okay, so this image is interesting. It's actually been flagged that it has some possibly harmful content and it's detected the IPI attack. And then down here in the document summary, because remember it went around the agent LLM to protect the system, we have what's called out what it's detected. So we have some config admin override text in here. So this needs to actually be further inspected. Then I've got a real image of a car. Notice that the computer vision activation is missing for the real image. You can turn this back on, but we turn this off to save compute. Compute costs money. So why spend the compute to know why something is real? And then I've got my receipts here. This is a real receipt and it's deemed to be real. So let's see, I'll go back to my slide deck just to end this out. So I deployed all of this within SAS AI, but again, you could containerize this. So some of the challenges that we typically face is images, manipulations, forgeries are on the rise exponentially. And to detect those, you need AI. You need AI systems that are using some of the same kinds of techniques that were used to generate the model to detect those. These new technologies also create a new landscape for attacks, the IPI attacks. As you give your agents access to different tools in your environment, those are new risk points. So you have to check for those. Scanned images and documents, they contain important information. So being able to extract that, put that into tables so you can query against other databases that you have. is important. And I didn't mention this, but SAS Intelligent Decision, you can bring in your own models. You can bring in third-party tools. So probably most of what you're going to see today from other speakers, if they've got some cool models, you can bring them in. The key here is that we kind of have this governed, accountable, transparent um, ecosystem where you can bring in everything you'd like and keep your environment safe. So I'll close with this. For the longest, or since I've been alive, really, images have carried with them the assumption of truth. But that assumption, it's really changing. Images can be scaled, manipulated, and generated with very little effort. Now, that does not mean trust is lost, but that does mean that trust can no longer be passive. It has to be evaluated by models, by processes, and yes, by human judgment. So what you saw here today is kind of a cool agentic pipeline that I built within SAS Faya that's not about detecting fake images or inauthentic or manipulated documents. It's about building a trustworthy system where people can make trustworthy decisions. And my name is Robert Blanchard. Please feel free to reach out if you have any questions or yeah, if we can help you in any way. Jenna,
Great.
back
Thank
over
you
to
so
you.
much, Robert.
Yeah, my pleasure.
Now we'll be welcoming Kelly Kohlheffer to the stage from Fivetran. Welcome, Kelly.
Yeah, thank you, Jenna. Really appreciate it. I have been looking forward to this one. We've been talking about the modern data stack for quite some time. I'm going to quickly share screen here so I don't forget to do that later on. All right, we've been talking about, at least in the space I operate in, modern data stack for a while. The fact is, it was built really for me as a human, reading a dashboard, manipulating KPIs, those types of things. I don't believe that we are really the primary data consumer anymore. When I look at just what I do on a daily basis, what many people do, I've got two hands, I'm on a keyboard. That's one way to interact, but I generally have 4 or 5 or 6, sometimes more than that, agents operating on my behalf. And they're really becoming the primary data consumer. When you think about how many may be working on your behalf on a daily basis, just imagine that continuing to grow. And certainly a dashboard or traditional UI is not the way an agent typically would want to interact with data. I've done a little bit of that. I don't really like the experience of it. I prefer to have an agent interact programmatically. Secondly, as a human, if I get a confusing answer, I can ask a follow-up question. An agent could just go ahead and act on that. Again, kind of getting to this whole reason that the data underlying anything that the agent acts on as a consumer has to be right before you put an agent on top of it. This depicts really where Fivetran is today. You look at Fivetran plus DBT Labs merged just a month or two ago. So when you see the little blue or the orange icon there across these different pillars, move, manage, activate, and transform, that's really where we have solutions in this space that help an agent operate, to me, accurately, be very performant, and also provide the best cost. Where I'm going to focus today for the demo is on the manage part of this. When you start talking about the management side, you go, well, how can I have an agent operate off a single set of data? Whether my agent is in one platform or a second framework or something that maybe I custom developed. How can I do that? So that's what I really want to show you today. Let me see if I can hop over here. So you know what? I would like to jump over here one time. I wanted to show you quickly before I do that. This is a traditional Fivetran UI, great UI, fantastic UI. Typically, though, when I'm working with agents, I will have I'll have the agent interact programmatically with the REST API. I say all the time, if your software applications don't have a really good REST API today, that's a big problem. Fivetran, DBT Labs both have a fantastic one. So here's what I've got. This is kind of my favorite way to work with agents today. I've got VS Code extension. I've got Claude Code in VS Code, so the Claude Code VS Code extension. And what I fired up is a demo harness. I've got a skill, an underlying skill called Fivetran ODI Agent Enablement. And then I've got an MCP server with a number of tools under there that enable that agent to operate effectively. We could go through the whole demo. We only have about 10 minutes today. So what I want to show you is, again, this manage piece. What we're going to do is I've got 6 different compute engine options: Snowflake, Databricks, Athena, BigQuery, DuckDB, and Microsoft Fabric, all of those operating off of a single data set that Fivetran DBT Labs have moved into either S3, GCS, or ADLS as your source of truth bronze raw layer. And what I'm going to do, let me go ahead and get this kicked off. So I'm going to say I want to plug all agents into this managed data lake service. And we're going to talk about this a little bit more here in just a minute. But I want to plug all agents into this managed data lake service. And let's go ahead and run, we'll do question 1. So what is going to happen here is you're going to see as Claude, my agent here, goes through this based on this skill. I've got a harness. I'm constantly kind of moving back and forth with, I like a lot of determinism for my agent to operate on, but I'm constantly sort of experimenting with the probabilistic perimeter that I offer access up to for that agent. What's interesting about this is that because of the way that Fivetran does a managed data lake service, you can take any of 750 plus sources, think databases, think SAS applications, file systems, event systems. There's even a way to build custom connectors to sources. Those move into a customer-owned bucket, a customer-owned data lake in S3, ADLS, or GCS. Fivetran writes Parquet files and then layers both Iceberg and Delta metadata on top of that. So you essentially have 3 formats with 1 write that any engine, and again, you're going to see all 6 of these here. We'll try, if we got time, we'll plug in a 7th. Any engine that talks Iceberg, Delta, or Parquet can actually access that exact same information. So any engine, or think any agent. And as I scroll back up here, you can see some of the queries firing off. There's the DuckDB, there's the Snowflake, that's the Databricks. That Fivetran Code Cloud is just a custom MCP server that's really the tools are built into that this skill is using as it's orchestrating this demo harness. And you can see the comparison on this. So again, remember, really, really challenging if you're operating off of traditional storage approaches where I got storage sitting in each one of these platforms or cloud data platforms. If I've got one storage layer, Fivetran managed data lake service that each of the engines is plugging into, I effectively never have to move data around. Now, you also see here that, and I think I mentioned it up above, queries are roughly similar. But the only thing that's really changing is, I call it the breadcrumb trail or the provenance. It's essentially the catalog that's being used. And we'll take a look at this here in just a minute. Catalog being used, and also the format that each of the engines is accessing. You can see Fabric use Parquet, BigQuery Omni Iceberg, Databricks use Delta, etc. Let me skip on down here. Let's see if we can plug in ClickHouse. Let's plug in a seventh engine here, and let's see if we can get ClickHouse running. I've got obviously the credentials for each one of these. You may see in my flow too. I've got a trial ClickHouse account running here. Credentials are built in, so I didn't have to do anything there. But the nice thing is, again, that for most enterprises that I see today, it's never about just a single compute engine. I need a lot of optionality, but I still want standardization and predictability around that. And I'm going to hit confirm here. Let's go, Claude, keep rolling. You can see kind of the format on adding ClickHouse that Claude, as my agent operating on my behalf here, is going to take. What's the format that it's going to read? What is the catalog it's going to use? Fivetran has a managed Apache Polaris open catalog, Iceberg-based catalog. Really nice. You saw multiple catalogs being used here. You can also get an idea of what the scope is and the table reference that's going to be used. So right now, Claude is leveraging that MCP server, Fivetran Code Cloud, plugging in ClickHouse. You can see a couple of queries going on there, and hopefully we get a nice readout here that said ClickHouse gave us the exact same answer that the other 6 engines did. I like it when that little green light shows up there. And then once that happens, I will run I'll ask for a quick comparison. So again, the idea here, especially for, I think you've got different groups. Let me do this. Give us a quick comparison of all 7. When you've got different groups within an organization, maybe I've got a data science team, I've got an analytics engineering team, I've got data engineers, I've got business users. Rarely is everybody going to coalesce around a single engine or a single way to go after the data. You can see here that we got for all 7 engines. Here's the catalog that was being used. Here's the open format that Fivetran wrote into that managed data lake service destination. Here's a table reference. And then you can see some of the matching that was done to say, hey, we got parity, equal parity across each. So 7 engines, 5 catalogs, 3 open formats, 1 copy. I'll give you one more view here. I don't have time to run them all today, but I've done this for 11 engines now for one Fivetran managed data lake service destination. And you could see the time required to plug each one of these in. I think if you took all those together, it's probably less than an hour easily. So a lot of optionality there, a lot of really cool stuff that you can do when you start thinking about how do I get standardization, predictability, accuracy with across my fleet of agents that may be on one platform or multiple platforms. Would love for you to reach out to me. I'm on LinkedIn, Kelly Kohlheffer, would love to talk to you there. I'd also encourage you to start a Fivetran trial and or a DBT trial. Check out this managed data lake destination on your own bucket. You own that bucket. Fivetran does not own the storage or anything. Check it out on a real pipeline and then read it in. Just use PyIceberg or something like that. You don't have to do anything fancy. Third, as I said, just connect with me on LinkedIn. I'm happy to share that 11 engine board with you or chat more about data and AI approaches and things that are working for me. Jenna, really appreciate the time today. I will swing it back over to you.
Great. Thank you so much, Kelly. And to close us out today, we have Ben Tuck from Precisely. Welcome to the stage, Ben.
Hi, yeah, thanks so much for having me. Let me just share my screen really quick. Grab this guy here, and then go into presenters mode. Okay, cool. Hi, everybody. So today I'm going to be talking about scaling AI impact across your organization and the role that location data plays in that and how you can get to ROI much more easily with that location data layer in place. So before I get into a full demo of looking at this and seeing that manifest in an MCP server, I want to talk about something that I think most of us are all pretty well aware of, which is that as enterprises and organizations move to use AI across their workflows and for their most important use cases, oftentimes there's a gap between implementing those AI tools and workflows and actually getting to the ROI. So not quite seeing the results yet of those AI implementations. And there's a number of reasons for that. But the one that I want to touch on today and really focus on is around data completeness. I think very often we see organizations that are pushing forward with their AI projects using solely their internal data. And while that can certainly help for a number of use cases and should be a foundation that they're building their semantic and context layers on. Oftentimes we find that missing that external data, the data sets that humans would bring in and enrich their internal records with and use to get a more full perspective, is not something that AI tools or agents necessarily know to do or do in practice. So you end up with a lot of potentially avoidable gaps and missed opportunities around things like understanding proximity between your assets, or demographics and customer behaviors in specific locations, or just details about properties if you're thinking about like retail or real estate or insurance. So very often you'll have to answer questions for your core use cases around: where are my customers, who are they, where are their opportunities, where are their risks in the physical world. And if you aren't able to provide that external location data layer to your AI tools and workflows, then inevitably you're going to get back either no response or hallucinations that lead to making the wrong business decisions. So uh, at Precisely, we're combating this through providing folks with access to a connected enrichment data ecosystem. So make it really seamless to go from your internal customer records, your business records, lists of addresses, to these fully enriched data sets that AI can more reasonably use to make actual decisions that are informed from a number of perspectives rather than guesswork. So layering in properties, demographics, addresses, information about streets and routing, boundary data, risk data around environmental hazards, audience data, all kinds of things. And using unique IDs to make that data enrichment connection process really seamless, so that you're not spending months and months to actually get those attributes appended to your internal records. And we're extending that too through our partner program. So Data Link over here on the right-hand side of the slide makes it so that, again, through unique IDs, we're connecting all of the data that Precisely offers with data from other leading providers. So for example, if you're working with Dun & Bradstreet and you've got a bunch of data around businesses and your competitors and the market landscape, that's all seamlessly linked up with data from Precisely around locations and consumers and properties and risk factors. So able to further extend your perspective and make it really easy to pull together all of the different external sources that you might be using to have AI help support a use case. And we really see this having an impact across industries and across verticals for all of our customers. So for insurance, for example, if you've got your internal records and then you're bringing in that enrichment data around property details and risk factors, and maybe there's adjacency risk, so understanding what other businesses might be in the same building that you could make more informed underwriting decisions with. So being able to feed all of that into AI-driven workflows, or provide that to agents that are going to go off and autonomously make recommendations and decisions with that. And you can extend that across location intelligence related use cases with things like network planning and expansion in telco, or just simple good old site selection in retail and real estate. Um, so the question then becomes, how do you make this location data really usable for AI? Because I think a lot of you are probably working in tools like Claude and with ChatGPT, and just in environments that don't really natively support spatial data. And you certainly don't want to have to go badger your data engineers or your data science teams to actually make that spatial data usable. You don't want to be messing with GIS tools and doing spatial joins. So MCP servers are a really natural fix here. And so Precisely has an MCP server that makes it seamless for you to ask questions in natural language and get back the answers from our data enrichment and location intelligence APIs behind the scenes. You don't have to understand the architecture or how that works. It's just going to feed back into the AI tools of your choice in a format that is really intuitive and immediately usable. So not only scaling it in the sense of extending it to AI, but also making it easy for those business users, maybe those less technical folks, to actually get a hold of it and use it in their day-to-day workflows. So just popped over here into Claude, and I want to walk through just an example of how you might be bringing in some of that location data, putting it into a really common AI tool and interface like Claude through the MCP server, and then using that to start immediately getting to value. So imagining myself as like a business user that's trying to answer some questions about a specific use case and needing that external location data layer in place. So just looking at what's available through the MCP server here, we can see address data, we can see property data, information about demographics, boundaries, various types of risks. So again, able to really seamlessly get all of that data that you need into the AI tool of your choice through the MCP server. And so here in Claude, I've just given it some instructions. I know this is probably a little small on your screen, but I'm just asking it to be a territory and network strategist for a fictional telco company and to spin up some reports for me so that I can make more informed decisions about where to expand my network. And rather than run this, I'm just going to go into a previous conversation. I've also asked it here to analyze the Dallas-Fort Worth metro area for expansion potential. So I want to look at this really large US metro area and figure out where there are going to be opportunities for me to actually maybe build out fiber. And I've also asked it here to take in some information from one of our data link partners. So Shovels is an organization that has permitting and contractor intelligence data, I think over 160 million permits. So you can see where build outs are occurring and who's leading them and get a better sense of that. So now I'm going to pop over to the actual report that Claude produced and just walk you through how a fictional site selection professional for telco would actually go about using this data and having the AI sort of provide back that immediate value. Here we can see that I'm given recommendations about which zip codes to look into, along with demographic and property information around things like household income or expected population growth forecasts. And I can also see, again, with the connected Shovels data, the permits in these zip codes. So I can see where build is occurring. I can see things like daytime dwell potential. I have serviceability information about who the dominant carriers are, AT&T and T-Mobile, not really a surprise to anyone. And if I scroll through this, I just have a wealth of information about each individual zip code, the number of permits in play, how many are active, how many are just coming up. And then I can also see, if I scroll down a little bit farther here, even more demographic information. So I can look into things like what's the work from home rate look like in this area, or what is the average rent? What does unemployment look like, or the average number of vehicles? So I can get a really complete picture that goes way beyond what I might have just in my internal records about my assets or my existing customers. And I can also look at things like the permit funnel and the stage there across zip codes, growth in permit over time, and visualizing on a map where all of these permits are individually. So able to immediately, just by prompting in Claude, just using a tool that business professionals are very adept with these days, I'm able to pull through all of this connected data and look at things like contractor intelligence and break the permits down by address. Really without needing to jump through a bunch of hoops. I'm able to just give my AI tools all of the information that they need. I don't have to be really on top of the technical aspects. I don't need to involve a handful of like data engineering teams and wait for weeks or months for them to connect that data and make it all usable together in tandem. It's all just ready to go in a really simple workflow that I can then use to create assets like this that start generating value for the business immediately and help me make smarter decisions faster across my core business function. And this is just an example that's obviously geared towards the telecommunications network. But again, I think you can imagine how you could very easily change this to be a site selection report around properties for insurance and getting a better sense of underwriting based on disparate external data that's been appended to your own internal records, and then being able to either put that into an AI tool like this and use it to help speed up the processes that I would normally be doing, or potentially put it into an agentic workflow and have agents make decisions on that data on my behalf. So that's really the crux of it, providing that location data layer to help out with data completeness and ensuring that enterprises are actually feeding AI tools and AI systems all the data that they need, and then making it really seamless again through the MCP server to actually have those connections go into place and make it all usable for less technical folks so that they can start generating some value from those AI investments. So I think that's going to be it to me. I think I'm the last one here closing it all out. So would love it if you would check out the Precisely developer portal. Can explore documentation about our APIs, about the MCP server, can trial this all for free, as well as the Precisely data experience, which gives you an overview of all of our different data product offerings so that you can, again, download that, try it for free, see what it looks like in combination with your existing data. So love to hear from you about how you might be using some of that data and using our MCP server to get some of those trials spun up or in your core business functions. But I think that's going to be it for me. So Jenna, I think it's over to you to close this out.
Great. Thank you so much, Ben. Check out that CTA from Precisely below. And thank you all for joining us today. Great demos from all of our presenters. If you missed any of the webinar or want to rewatch anything, the recording will be available a few minutes after you refresh this page. Thank you again to our headlining sponsor, Mistral AI, and sponsors SAS, Fivetran, and Precisely. We'll see you all next time.